In this video, we are going to be doing number 19 in Chapter 4 of the AP Physics textbook on page 103. A place kicker must kick a football from a point 36 meters from the goal. Half the crowd hopes that the ball will clear the crossbar, which is 3.05 meters high. When kicked, the ball leaves the ground with a speed of 20 meters per second at an angle of 53 degrees to the horizontal. A. By how much does the ball clear or fall short of clearing the crossbar? B. Does the ball approach the crossbar while still rising or falling? Let's start by visualizing the problem. I'm aware that this problem is not proportional. So it says that the crossbar in the horizontal direction is 36 meters away. So let's say that's about that much. And it says it is 3.05 meters high. So the trajectory is going to look something like that. And we don't know if the football goes over the crossbar or if it goes under the crossbar. Now this is a projectile launched at an angle, so the next best thing to do is to calculate the horizontal and vertical components of the speed. So the horizontal component is going to be 20 times the cosine of 53 degrees, which is 12.04 meters per second. And then in the vertical direction, it's going to be 20 sine 53 degrees. That'll be 15.97 meters per second. So the first part of the problem asks, by how much does the ball clear or fall short of clearing the crossbar? So essentially what we want to do for that one is we want to figure out its y position when it is at an x position at 36. If we can find out at what time the ball gets to 36 meters, then we can figure out what its vertical position will be at that time. If we are looking for, we're looking for time if we know that x is 36. So for that part, we can just rearrange our ninth grade equation. So v equals distance over time. If we solve that equation for time, we get distance divided by speed. Our distance is 36. Our speed is 12.04. Remember, this is just for the horizontal direction. So we get t equals 2.99 seconds. So at 2.99 seconds, the ball will be here horizontally. Now, how would we figure out it vertically? Well, we know that our initial y is 0. It's on the ground. We're looking for yf. We know that the acceleration in the y direction is negative 9.8, and we just figured out the time. So it looks to me like we need to use our second kinematic. So yf equals yi plus viyt plus 1/2 at squared. We're looking for yf, so we say yf. This term goes away because it's 0. So if you plug that all into your calculator, you should get that its y position is 3.94, which means it clears the crossbar However, it asks by how much. So to do that, we need to do 3.94 minus 3.05 equals 0.89. So our final answer for part A of the problem is it clears the crossbar by 0.89 meters. Let's do part B. Part B says, does the ball approach the crossbar while still rising or falling? So in other words, is the ball going like that, or is it going like that? That's how I drew it. The easiest way to do that is to figure out at what time the ball reaches its highest height. Now, when the ball is at its highest height, what will its velocity be? Well, in the x direction, it's going to be the same as it always was, so that doesn't help. But in the y direction, it's going to be 0. So what we want to do for this part of the problem is use our first kinematic to solve for time. So we're going to say, that's part A, starting part B, VFY equals VIY plus AT. So we know that when it reaches its highest height, its velocity will be 0. Its initial speed in the y direction is 15.97. And acceleration is negative 9.8, and we are solving for t. If you solve that out for t, you should get that t equals 1.63 seconds. What that means is that the ball reaches its highest height at 1.63 seconds. It crosses the crossbar, which we calculated earlier, at 2.99 seconds. That means it clears the crossbar not while ascending, but while falling, which again is how I drew the problem. That was just a guess on my part. So the way we answer that one is while falling.